Hi, this is an instructional video for A-level maths, pure 1, on the topic of differentiation from first principles. This question is taken from the May 2018 AS Pure exam paper. The question reads, prove from first principles that the derivative of x cubed is 3x squared, and it's worth 4 marks. So it's basically saying prove that when you differentiate x cubed, you get 3x squared. So I've drawn a diagram here to roughly illustrate where we get the formula. I've just drawn any old curve because it doesn't really matter. That's in red. And in blue, I've drawn a chord. And this is going to help us estimate what the gradient is at a point here. So instead of substituting numbers, I've used x as the x coordinate for my first value. And obviously to get the y coordinate, I would do f of x. The next coordinate, I've done x plus h. So that is just adding on a very, very small value. Really small, almost so small it's insignificant. Then, obviously, to get the y value for that coordinate, I will have to do f of x plus h, because I have got 2 different x coordinates. By creating this chord, I can also create a right-angled triangle, and this will help me do rise divided by run, which you would have done at GCSE, and that is how you work out the gradient. Now, the rise is the difference between the y coordinates. Well, my 2 y coordinates are in terms of f, or f of x. So I've got the first coordinate, f of x plus h, minus f of x. That's my rise, and my run is the difference between the x coordinates, x plus h minus x, just to give me this width. So my formula overall, the one that you will use for every question asking you to use differentiation from first principles, is f of x plus h minus f of x all over h. So now we've got the formula, we can work on solving the problem. So f of x, we know, is x cubed. For f of x plus h, wherever I see an x, I'm going to replace it with x plus h. And I'm going to substitute into this formula the values that I need. So f of x plus h, well, it's cubed. Instead of x cubed, I'm going to have x plus h cubed. Don't forget we have to do minus f of x afterwards, so I've got minus x cubed, and all of that is over h. And remember that h is just a really small number, just a really small thing that we're adding on. We've zoomed in loads just to create a small difference for us to estimate the gradient from. Now the next step is to expand our bracket, and you could do that by doing x plus h squared and then multiplying by x plus h again, or you could use your expanding binomials. Doesn't really matter. No matter what you do, when you expand it, you'll get x cubed plus 3hx squared plus 3h squared x plus h cubed. So that's the expansion of x plus h cubed, but don't forget we have minus x cubed on the end as well. And all of that is over h, that very small number that we've added on to give us a second coordinate to get the gradient from. Well, now it's just a case of simplifying. So we've got x cubed, take away x cubed, right? Easy, sorted, they've gone. Everything else has got an h value in, so I can cancel out my denominator. So I've got 3x squared, that's looking promising, plus 3hx plus h squared. So now what we can do is we can say that, well, h is tiny. H is it's basically nothing. It's basically 0. So if h is basically 0, then we are adding a 0 here, and we are multiplying by 0 here. So as h tends towards 0, well, that just means h is so small it's getting towards 0, 3x squared plus 3hx plus h squared, well, that's going to tend towards 3x squared. The h's are getting so small, they may as well be 0, so I can just get rid of them. Multiply through by 0. So now we have proved that the derivative of x cubed is 3x squared using differentiation from first principles.